think it's that motivating vision that I actually see animating a lot of the work that we do in this field as well. Another major influence for me, perhaps unsurprisingly, is the work of the French cartographer and designer Jeffrey Heer, who just 1 year previous to the mother of all demos published the first version of the semiology of graphics, really initiating, in my mind, a systematic study of visual encodings as a science system tied to a notion of underlying data types or variables that have a really interesting connection to the types of perceptual comparisons that we might make. So for example, in terms of nominal, ordinal, and quantitative data. And really, I think, laying a foundation of concepts that motivates a lot of the research ongoing in our field today. And the third example actually comes from a really interesting piece of writing a few years earlier to this, done in part by the famous statistician John Wilder Tukey, who back in 1966 with his collaborator Martin Wilk wrote an article, Data Analysis and Statistics, and importantly separating the two, noting the role of statistics as basically a subset of the larger process of data analysis and trying to think through what the appropriate integration and roles of those are. And this particular article has been so influential to me, I like to just share a few excerpts from it. Very useful for motivating talks in our area, in which Tukey and Wilk write, 4 major influences act on data analysis today. 1, the formal theories of statistics. 2, accelerating developments in computers and display devices. 3, the challenge in many fields of more and larger bodies of data. And 4, the emphasis on quantification in a wide variety of disciplines. I love how this is this succinct encapsulation of the big data era from over 50 years ago. Right? While some of the influences of statistical theory on data analysis have been helpful, others have not. Exposure, and interestingly, he does not use the word visualization. We'll get back to my title later. The effect of laying open of the data to display the unanticipated is to us a major portion of this larger process of data analysis. It is not clear how the informality and flexibility appropriate to the exploratory character of exposure can be fitted into any of the structures of formal statistics so far proposed. Accordingly, both approaches and techniques need to be structured so as to facilitate human involvement and intervention. Some implications for effective analysis are: 1, it is essential to have convenience of interaction of people and intermediate results. And 2, at all stages of data analysis, the outputs need to be matched to the capabilities of the people who use it and want it. And I think it's really just incredible to have one of the foremost statisticians of the time have rhetoric this strong, challenging his own field, basically saying this was his, talk. Statistics is not enough. That could be for a separate conference. And so this, of course, was the beginning of a really interesting line of work, not just including, ideas around exploratory data analysis, but real technological developments as well. Many of you are probably familiar with Tukey's work with Marian Fisher-Keller and Jerome Friedman on Prim9, where back in the early 70s, working at the Stanford Linear Accelerators Center, they actually did custom hardware to support interactive graphics for picturing, rotation, isolation, and masking in 9 dimensions. The system was literally named after the interactive tasks it supports. So that includes things that we are used to today, including, for example, interactive configuration, dimensionality reduction techniques, as well as filtering, which by today we would call dynamic queries. They're implemented again, decades before others in our field coined that term. And this led to other works in statistical graphics, including, for example, things like multi-view displays generated by computers, supporting techniques such as brushing and linking. So many of the things that are still core to what we do today actually have a very long lineage, at least relative to our individual lifetimes. And so one of the things I love about working in visualization as a field, which makes it so enriching and fun, is that we have this deep interdisciplinary combination of ideas from various fields. And if this graphic were more accurate, it wouldn't be showing straight arrows, it would be kind of illustrating how they're intertwined, how ideas from different fields are actually being combined in novel ways to enable new experiences and ideas. And so this is one of the things that, again, I want to celebrate and I think is wonderful, but also, I think prompts some interesting reflection. So if you buy this argument so far, what it leads me to is to conjecture that one of the most important contributions of our field arise from interdisciplinary synthesis. So not staying within a single area of exploration, but really combining ideas from outside with sort of our existing motivations. And to put a little bit more weight behind this, let me share some examples that I'll draw from an area near and dear to my heart, which is visualization systems. So many of you are probably familiar with Jock McKinley's 1986 thesis on APT, a presentation tool for automatic chart design. think one of the earlier works that I think we can really lay claim to as a community. Here the idea was you'd have an input data set along with a priority ordered list of variables, and it would search over the space of visualization designs and try and give you a good design based on perceptual principles. So for example, here mapping the first two variables considered the most important to X and Y, then mapping something categorical or ordinal like repair to color, and then something quantitative like weight to an area encoding. And this itself is a really interesting example of combining interdisciplinary ideas. Using Bertrand's semiology as a representation for thinking about how you might enumerate a space of charts, using nascent results in the field of graphical perception to guide the choice of chart designs, and then using, at the time, state-of-the-art artificial intelligence techniques in the form of logic programming to bring this all together into an interactive system. And if we kind of peel back the graph one layer here, of course, all of these inputs are themselves very interesting intertwinings of interdisciplinary ideas. So, having done this, I then thought, well, could I apply a similar diagramming to some of my own work? And so, for example, here you see some of the toolkits that my collaborators and I have worked on over the years, including Predictive, Protoviz, D3, and Vega. And then later, systems that are trying to use these as underlying infrastructure to support automatic design or exploratory analysis. You might note some clusterings here. You can see kind of an era of work where we're focusing on how do you specify a visualization, particularly interactive visualizations, and what are the mechanisms for doing that. And then down here you see this transition really into visualization guidance. How do you build this infrastructure? How do we actually use it more effectively? All that said, the one thing that really jumped out to me though is that here, now highlighted, here are all the ideas that I would not say come from our field. That many of the motivations came from looking at new programming language paradigms, ideas from databases, or ideas from other areas that really gave us a new perspective on how to approach this, either in terms of what our motivations were, our overall design strategy, or what were the key technical innovations that allowed us to push these systems forward. So again, I'm hopefully convincing you, if you weren't already on board, that some of the most important contributions do arise from this interdisciplinary synthesis. And if you buy that, then you can draw a corollary that, therefore the practice of this principle of interdisciplinary thinking is our greatest asset. And so far we've been really applying that to the development of new interactive visual interfaces, and we should continue to do so. But I think we can also apply this skill more broadly. So if we have this interdisciplinary connection into Viz, it's natural to ask, how do we go forward? What are the additional ideas we might bring to push our field in interesting ways? But as a sanity check, we might also ask, well, if the interdisciplinary combinations that we're coming up with really are valuable, are they having an effect on the, kind of the upstream disciplines? Are we actually changing, not just being changed by these other fields, but changing them back in turn? As potentially one heuristic for thinking about the health and vibrancy of the ideas in our field. And so these are some of the things that I was reflecting on as I tried to prepare this talk. And so I will continue on this celebratory note with what I think is another piece of good news, is that this example of disciplines informing each other is certainly alive and well in subsets of our field. In recent years, I've been particularly impressed with the relationship between the data management field, so particularly databases, but also data mining, with the Viz community. So seeing core ideas from databases permeate into Viz to enable new forms of scalable interaction. But at the same time, the use cases, needs, interaction models, etc., requirements, changing how database researchers are doing their work, including seeing people in both fields stake their careers on this interdisciplinary intersection. We see that in some of the papers published at the conference here. You'll see it if you go over to Sigmod and BLDB. And perhaps most fun, you see this in a collection of workshops being organized jointly by our communities across all of these different conferences. So here's a place where I'm actually really seeing new ideas on how database systems need to be built to respond to the needs of interactive analysis, for example, as opposed to just pre-specified query workloads. So here's one example of the types of successes I think we can achieve, but I think we can do more. So that was the celebratory part. Now there's also the fact that we also live in an interesting age where not everything is so rosy. And there's a number of larger societal challenges that I think our field is well positioned to contribute to. So let's take a step back and think about this. As many as you know, we're still currently undergoing a data explosion, where the amount of data available is outpacing Moore's law. In this case, it's almost like a 30x increase in the amount of stored data over the last 10 years. And not all of this is a good thing. But certainly it's been driving a lot of interest. We have big data and now AI hype. but also really a rich proliferation of tools. So as a proxy for that, I just found the download counts for some popular data analysis tools. So ggplot and dplyr, if you don't know, are popular data visualization and preparation tools in the R statistical programming environment. And Jupyter, of course, being like Jupyter Lab and Jupyter Notebooks, particularly popular among Python programmers. And these are all growing at super linear rates. And so what we're seeing is an influx of lots more people getting involved in working with data to do analysis and try and drive decisions or new products. However, I think there's some corresponding dangers. So with this, there's many more tools and there's lots of tutorials that are tool-based, but are the appropriate methodologies in place? Is this use of tools actually outpacing analysis expertise? And it's an imperfect proxy, but what I found was the number of statistics master's degrees granted in the United States. It looks like it's flatlined here. Maybe it's a bit fairer to put it on a log scale. But you can see, for example, the growth and adoption of tools seems to be outpacing the rate at which people might be learning these methodologies. So I think this creates this ripe potential for what I might call data abuse. And I think we're seeing this writ large in society today. Everything from data curation and access policies. So for example, kind of the travesty of people's personal data being harvested by Cambridge Analytica. And the travesty of being served cheap ads to learn machine learning and advanced analytics while I'm reading an article. And these are the types of things that will onboard people onto tools, but maybe without the proper understanding of how to put them best into use. As many of you well know, replication crises are roiling certain sub-areas of science where kind of bad statistical hygiene or just honest but unfortunate practices have undermined even decades of results. And again, these are problems that I think we can help contribute to. Here's something just as simple as bad, spreadsheet arithmetic resulting in flawed, economic papers, or then used as the basis for national economic policies, including austerity measures, but perhaps improperly. Again, based to, from a certain perspective, might seem like rather trivial data mistakes. And then, of course, we have people's interactions with artificial intelligence, through various types of predictive services. So some of you may be familiar with Tay, which was a tweet bot, basically put out on Twitter by Microsoft that went from humans are super cool to full Nazi in less than 24 hours. And so this writer, of course, is not at all concerned about the future of artificial intelligence. And this is an example of what one of my colleagues, John Miles White of Facebook, says, basically the manipulation of input training data is the SQL injection attack of machine learning. And so here's you have people intentionally fueling data into a system to drive it into, in this case, antisocial behavior. And even, ostensibly otherwise well-intentioned companies, either due to poor data collection or poor quality assurance, might release predictive products that are actually very dehumanizing. And again, these are all aspects of human interaction and human engagement with data that I think is really a hallmark of the things our field tends to think about. And this happens in mundane, perhaps more mundane, but still important situations as well. For example, Facebook ran into a lot of problems with their advertisers. It turns out they overestimated a key video metric that their advertisers used to allocate their budget. And so they actually faced an existential threat to their business if their advertisers revolted. And this gets less headlines than some of the other things, but I know this caused some existential crisis within the company itself. And again, this was basically due to bad data preparation. And so, this is actually, all these types of things led the United States branch of the Association for Computing Machinery to write to the US Senate. The nature, scale, depth, and consequences of the data, technical, and ethical breaches understood to have occurred thus far are unlikely to be confined to a single company, technology, or industry. So I think these really are societal scale problems and ones that really should be kind of in our wheelhouse as being potential contributors. So put more simply, people's interaction with data is subject to misuse and abuse. Here's just some examples of how analysis might go awry. Poor decisions or operations due to faulty inferences, inaccurate models due to bias or inaccurate data, insufficient accountability and review of analysis procedures, and a lack of monitoring and enforcement of data usage patterns, and all apply to the examples I've shown. And interestingly, all these problems arise not just in one sort of thing. It's not just p-hacking a particular type of statistical model, but it's really problems that arise throughout the end-to-end analysis workflows. Kind of messy business of where people are making subjective or heuristic decisions on how to proceed in their work with data. And so this has led me over the previous years to really shift my thinking from as a visualization researcher to what I really think of like an interactive data analysis researcher. Perhaps this seems a little bit self-serving. This goes all the way back to 2013, when my group took a long walk from Stanford up to Seattle. But in the process, we intentionally renamed ourselves from the Stanford Visualization Group to the Interactive Data Lab to really try and focus on what is the actual phenomenon that we're really trying to study and then hopefully improve. And so I think really what we should be thinking about, and I know many of you already are to some degree, is the end-to-end data analysis lifecycle. Everything from where this data is coming from, what are all the analysis procedures, whether they're visual or not, and then what are the outcomes, whether that's in terms of human decision making or in, for example, predictive or other types of models that are being deployed in production. And so this could be our phenomenon of study, including, and you can challenge different aspects of this, but like understanding what are the composite tasks that people engage in, from data collection all the way through to deployment or decision making. And we can take a viewpoint that our field's very good at constructive, forward-thinking stuff, but I think it's also valuable to take an approach that might be more akin to what you think of with software engineering or security. Think about what are all the points at which this process could break down. So that's everything from selection bias and collection to errors and labeling, all the way out to deployments that were improperly tested, or models were trained, but then the actual distributions of behavior are changing over time and the models become out of sync and we need monitoring. To, of course, everything in between here. I think considering any one of these points actually can lead to a number of interesting research ideas on ideas for both improved methodology and tools. So within visualization, I think we're really good at focusing on these bits so far, including exploratory analysis and data quality assessment, typically prior to more engaged modeling. And also, we can do more, but I think, we certainly recognize the importance of communication and narrative visualization as well in terms of what we do with the results of analysis. Obviously, still plenty of work to do in these boxes, but I think looking at the broader pipeline will give us even more promising areas to work in. Where I'd say traditionally statistics has been primarily concerned here with model fitting and evaluation, in which, obviously we already have a number of issues, in part because the human nature of this process was insufficiently addressed. If you view a single model in isolation, it's one thing, and you can talk about particular probabilities, but when people are making 20 different decisions and trying all these different models and not understanding what that does to their inferential validity, you have a larger human data interaction problem. So I'm really interested in trying to find what are these life cycle concerns that give us new handles on important research topics. Everything we're thinking about, what are the unaccounted effect of various collection and preparation decisions that we might not be accounting for at all in terms of how we think about the validity of our results. As well as interesting challenges in the interpretation and review of results, and particularly their application within ecologically valid decision-making contexts, something that's actually very, very hard to study well. Fortunately, there is lots of progress here. One area I'd like to call out in particular that I'm very excited about is an uncertainty visualization. This goes back, for example, to work by Cox and others, and more recent work by Lisa Padilla and colleagues, looking at things like visualizing hurricane tracks. So this is nice, 95% confidence interval view of a hurricane that a lay user confuses with, oh, that's the size of the hurricane at that point in time. Let alone, if you don't think about it in terms of a range, you might not realize that there is a non-zero probability that this hurricane could actually turn and head towards Texas. And so this notion of frequency framing that's coming out of psychology and decision-making literature has actually been a really interesting aid to some of this work. That people do better by visualizing these hypothetical outcomes. And this idea has been taken up in a number of more recent visualization projects, including Jessica Holman and collaborators' work on hypothetical outcome plots. And then work by Matt Kay and others on quantile dot plots. In this case, the data being looked at is just predicting when a bus will arrive. And you imagine that seems simple. You just take the probability distribution function and plot it and make a decision. But it turns out actually reducing the information actually leads people to reason with uncertainty better. So in this, just by taking simple steps in the cumulative distribution and using that to create a discrete dot plot with only a small number of points, like 10 or 20, actually results in better reasoning. Better estimates and decisions with time, and even the worst performers, the people who typically have the hardest time thinking through this uncertainty, actually improve with these displays. And they can be used for a variety of things, like in context, I can actually do a little reasoning based on my risk tolerance. How much do I want to risk, arriving late and missing the bus? I can actually make a very simple estimation that's actually helped by the fact that I've reduced the data. So sometimes these things are non-intuitive that actually have really interesting impacts on people's ability to reason effectively under uncertainty. This is an ongoing area of research, and in fact, Jessica Holman and Matt Kay just published some articles online helping describe this research field. So if you're interested in more, I would point you to those. And so while I'm incredibly excited about the developments in this area, and I think it's incredibly important, I would again sort of reiterate that, however, it's still not enough. And much remains to do throughout this life cycle. And I think focus on the purely visual might blind us to some of the more interesting challenges here that we can apply to. And it's not to say to avoid visualization, but to fixate on visualization being the solution before you've thought through what the nature of the problem is with people's interaction with data seems to me unnecessarily limiting. So I would say we need analysis support tools, and importantly, and methodologies for end-to-end analysis, and not thinking about it just in terms of siloed statistics or visualization tools, especially if we're not thinking about how they fit together within a larger methodology. And so I would say in terms of what we can develop as a field, reusable components and techniques that integrate into existing analysis environments are important. New work that extends popular analysis environment that allows our work to reach people, not just in our field, but doing this work in a variety of organizations. For example, by building into things like Jupyter or R and these other popular environments, might be a much better vector for impact than a bunch of one-off applications. And I say that as someone who has built or been responsible for a number of one-off applications, so don't worry, I'm certainly including myself in any critique here. And so I think while we draw a lot on analysis and certainly contribute back to it, for this larger process of analysis, the one that Tukey was talking about, where statistics is a piece, exposure is a piece, that as a phenomena of study I think is something we should really embrace. And again, I know many of you do this already, but I think as a field we could be doing more and making outsized contributions not just to each other, but to the other related disciplines and practitioners. And here's just one example that I've also found really inspiring. This is a paper by Simonson et al. Called the Multiverse Analysis Specification Curve. And so what they did was they took a number of papers, including one that you may have heard of. It's a bit controversial. A paper that appeared in PNAS, which stated as the result, hurricanes with female names are deadlier than hurricanes with male names. So this was a statistically significant result, but probably rightfully garnered some scrutiny. And so what they did here is say, okay, let's look at the modeling decisions they made, and let's try and come up with what is a space of reasonable specifications. Where that everything, like how did we include covariates? How did we operationalize the variables? For example, what does it mean to have a female name or a male name? What are certain decisions in terms of the choices of response variable and statistical model? And then let's just, instead of having one analysis and reporting that result, let's compute all, almost 2,000 analyses and see what happens. And in this case, what comes back, in certain conditions, you can actually flip the effect. The sign actually goes negative. Maybe those are actually, you discover that they're maybe not reasonable specifications, and so that could be useful. But the other thing they found was that less than 3% of all results actually obtain statistically significant results. And so here's a way of maybe trying to get beyond the dichotomous thinking of null hypothesis significance testing and thinking about the overall variability and sensitivity of our analysis processes. And how to specify these types of analyses and how to communicate them and explore them seems like a topic that our field would be uniquely positioned to do well. So, to sum up this particular thread, I think there's lots of great research opportunities to think about, including capturing and representing analyst activity. Like, what does it mean to do exploratory analysis, not just in terms of what we get into our heads, but how do we concretize that? How do we actually make that an output that other tools can then take as input, whether that's as a causal diagram or something else? As some recent work has looked at in terms of how multiple comparison problems come up even in exploratory viz, tracking behavior might also provide useful safeguards. And I was really influenced by Jessica Holman's statement she made in a conversation we had some months ago. She said, we need a science of elicitation. As a particular research topic, how do we get people's beliefs or leanings or findings in their heads and get them concretized in ways that we can actually make them part of formal reasoning processes? This is a hard challenge, but one that I think is incredibly exciting and one that we should be contributing to. Some other ideas, and I won't go into great depth in the interest of time, but tools for reviewing analysis or safeguarding it, maybe ways to try and combat some of those pitfalls I showed earlier. And then, as we just discussed, ways of specifying, optimizing, and presenting multiverse analyses, really trying to capture the end-to-end decision-making process, not just do evaluation subject to one little step in a larger pipeline. And then finally, I would just reiterate, my desire to see the community integrate and extend shared analysis environments to a greater degree than we currently are, as opposed to building one-off tools. With that, I'd like to transition to a slightly different but related topic, which is our interaction with machine learning models. Obviously, this is part of data analysis, but it's also taken on a larger outsized role as machine learning techniques are being commoditized into consumer services. And so you've probably seen these different headlines. The verdict is in, AI outperforms human lawyers in reviewing legal documents. It's like, I doubt it. And now the robots have achieved what humans never will, assembling an IKEA chair in less than 21 minutes. And so, one of you there is reading this and saying, challenge accepted. And this one, my former colleague at Stanford, Andrew Ng, someone I respect greatly, but I also question some of the statements they've been making in terms of AI hype. Should radiologists be worried about their jobs? Breaking news, we can now diagnose pneumonia from chest x-rays better than radiologists in tightly controlled situations with limited data sets, and a lack of context. And then, my personal favorite, just because it's ridiculous, Elon Musk's concerned that AI will become an immortal dictator from which we would never escape. And so that one's just there for fun. But the others all point to something I find quite disturbing, which is this sort of direction that both industry and a number of my academic colleagues go, which is this goal of pure automation, like taking ML and actually replacing human function with it, which I think is, at least at this point in time, likely to be highly flawed, but also not really constructive of the world that I want to live in. And I think it's something we can do something about. Unfortunately, some of the saner colleagues recognize this. So my collaborator, Fei Li, wrote, I worry that enthusiasm for AI is preventing us from reckoning with its looming effects on society. Really, AI should be enhancing us, not replacing us. And in a rebuke to his advisee, Andrew Ng, his advisor, Michael Jordan, wrote, we need well-thought-out interactions of humans and computers to solve our most pressing problems. And so I think it's fantastic that AI people are rediscovering the need to look at the combination of algorithms and people, but some of us have been doing this for a while, and I would like to see us better reflected and making stronger contributions in this conversation, because I think as a community we have a really important perspective to bring. And indeed, you're seeing some of this work, and both here in this conference and in recent events. Just a few that I would highlight. This is a paper out of Google on machine translation embeddings, where they're taking sentences with known semantics and then using a debugging by putting it into a projection of the latent space model, so the latent space of the translation model, to make sure those sentences actually project to similar areas. The idea is like I debug the model to see if it's actually capturing an underlying shared semantics. Here's one from Georgia Tech and Facebook, looking at both model architecture and then visualizing the activations within that network. And this was actually deployed at Facebook at a relatively large scale. There's work from Google by Chris Ola, Arvind Sachinarayan, and others, looking at ways to create visualization techniques, like what are the activations within, in this case, a CNN, convolutional neural network, and be able to do attributes for different areas of an image. How is it contributing to different classification decisions? And there's still lots of work to be done here, but it's still a really interesting space to explore, and if nothing else, you get pretty interesting psychedelic imagery. And then there's this lovely paper from Hendrik Strobel and collaborators, many of whom are at Harvard, on debugging sequence-to-sequence models for neural machine translation. And I highlight all of these projects. There are many other great ones in the community, but these ones in particular, because they all either are appearing in machine learning venues or having invited talks in those venues, and almost all of these papers involve authorship lists that are collaborative teams of visualization and machine learning, vision, or NLP researchers. So really starting to create this loop that I referred to earlier. And I'd like to see us do more of getting these ideas out and shared across communities. Though a lot of visualization and interpretability is great, I don't think it's everything. It is not enough. Why do I say that? Well, I think we should be doing more than just taking what the machine learning or other communities are producing and then trying to make it more interpretable. I would love to see us providing the guiding ideas that are changing the types of problems they're addressing and how they might be approaching them, particularly within the context of interactive systems. This might be a tall order, but I do think it's achievable. The design challenge here, one that's been noted since the 60s, later re-emphasized in the late 90s by Eric Horvitz, and now others are taking up, is thinking about how do we design quote-unquote regions of optimality in the possible division of labor among directed and automated actions. Or put another way, what are the design frameworks in which we can properly balance automation and user control? For particular tasks and available algorithms and data, what is the right balance? What is an engineering discipline that would allow us to figure out, which things we should be automating, or which things we might be, hard to automate now, but we really shouldn't waste too much time because it's going to be automated in the near future, versus the things that we really need, human oversight and guidance, and basically what these systems do to us as we use them as well. So just to briefly cover some of my concerns here. Obviously there can be problems with automation. I worry about people who are receiving recommendations and acting on them, losing critical engagement and not exercising necessary domain expertise. And of course there's problems where models may be insufficiently accurate, and we've seen poor consequences from bad models released into the world. Of course, I'll be the first to admit, we humans are far from perfect. We might have ambiguous intents that are hard to express, and AI technologies might actually help us refine those extents and even think creatively about problems in new ways. We don't scale well to repetitive tasks, and we also have our own mistakes in decision-making, sometimes categorized as cognitive biases, oftentimes because we lack a global, complete view of information, and so overweight local information, which is at the root of many of these cognitive heuristics people have identified. And so I think it's important for us to think about different strategies. Just one that we've explored in some of our work is this notion of shared representations. So by that I mean having a formal model of the actions that you can take. What are the various tasks that both people can reason in terms of, and the automated system can also reason in terms of. The idea being, what is the common ground that can actually make people and algorithms appropriate collaborators? So I can get recommendations that are not just out of the blue, but really align with my workflow in interesting ways. And how can we model these in ways that we can make useful suggestions or predictions that hopefully gracefully integrate into an interactive process? And so we've looked at this in a couple of domains. The first that was really formative for me was writing Data Wrangler with Sean Kendall and Joe Hellerstein, where the previous approach to preparing data for analysis was to write transformation code and then maybe visualize the output. And so really informed a lot by actually ideas from the database community, we sought to flip that. Start with visualizations, even if they're just simple tables or text or histograms, but then by interacting with them, so in this case maybe I want to extract that number of bedrooms from a listing of apartments, that actually serves as evidence, which is then input to a search procedure. In this case, then AI algorithms search over possible statements of how this data could be transformed in response, ranks them according to a predictive model, and then uses appropriate visual cues, in this case, to signal what the effect of that transformation would be. So really trying to turn this programming task into one of interactive guidance and selection. So we call this general approach predictive interaction, and it's also at the heart of the product we produce on we've commercialized Data Wrangler as Trifacta. But more importantly, this same type of approach we've been able to reapply in additional contexts. So for example, the Data Voyager project, led by Puneet Wongsapassawat, Dominic Moritz, and others, did a similar thing, but in this case the underlying language was Vega Lite, and the input is, I've created a chart, now I'm going to take that as a seed and use that to search for additional charts that form a search frontier within the process of exploratory analysis. So in this case, my initial visualization decisions are serving as guidance that are then driving a predictive process in which I can then choose to look at additional charts or just choose to ignore and dismiss them. Again, we want the human agency in the loop. And then finally, this is more recent work. We've taken the same approach and tried to apply it to the problem of error analysis. That is, given a thick collection of machine-learned models, how good are they? And for the errors that we observe in the validation set, can we begin to explain them and test them? So for example, in this context, we might look at visual question answering. This is where you're given an image and a text question, and the job of the algorithm that combines vision and NLP components is then try to answer that question. And you might say, well, how am I doing at questions that start with how many? And does it matter if I say how many noun, or if I say how many adjective something? Is that adjective actually hard to resolve? I might have a theory that that's why this thing's failing. And I might express that theory just by selecting the relevant words in that instance, and then giving suggestions of formal, reproducible, rerunnable queries that then isolate a class of instances that I want to analyze for errors. So So for example, I might look at the error rates for all instances versus things that say how many noun versus how many adjective, and do both, basically in this case, hypothesis and model comparison. But this is not enough. The key bit is to also be able to test these hypotheses. So we also have predictive interaction mechanisms for suggesting rewrite rules. So if I rewrite my instance data to remove a particular linguistic feature, do I flip the error label? Thus actually being able to establish a counterfactual of how well my model is working. And so this is actually work that we're going to be publishing at ACL later this summer. And it's not a visualization-heavy system, but it's the ideas and the driving motivations of the visualization field that led me and my collaborators to develop a system like this. So this is an example of something that I think would actually be very hard to publish at FAST, because they come back and say, no new visualizations. And if you doubt me, you can just read the reviews I got yesterday. I feel so not alone now. Just quickly to show a schematic of how this works, you might imagine that we have some kind of domain-specific language. Another way to think about this is really just kind of like chess playing algorithms, but instead of playing chess, we're playing data cleaning, we're playing EDA, or we're playing error analysis, right? But you start with that as a formal representation. Find some nice way, hopefully, to map it into a visual, graphical, or anyway, perceptible representation. Then you interact with that, and then that, you get immediate response in terms of like what the content you selected is. But then again, that's used as input to a search procedure from which you generate a series of predictions, which are really statements in that underlying language, that then can be previewed, and then from which the user might then select which thing they're interested in, or ignore it and go do something else instead and see that result. And at the end of the day, what you produce is not just that output, but actually the underlying program, which allows you to do things like reuse, scalability, reproducibility, et cetera, much better. And so we like to talk about this as what we call the guide-decide loop, as this interaction model where you're in control, you can do things directly if you want, you don't have to use assistance, but you can also provide evidence to these routines that then provide back recommendations that you can then review and then perhaps even just modify further if they're close but not exactly what you want. But again, this is just one approach that we've been exploring. I'd be really excited to hear ideas that you have. There might be different interaction paradigms for machine learning infused systems. And so while this area of effective AI infused interactive systems is certainly larger than visualization, I think it's something that we can meaningfully contribute to. We all need to challenge these fully automated assumptions, and I think we can develop new interaction paradigms. We also need to build better prototyping tools, because these systems that I've showed you take too long to build. So the underlying infrastructure challenges are interesting. And hopefully they can enable a virtuous cycle of human and machine learning, is that people can use these systems and actually gain expertise from the types of principled, hopefully, recommendations being made. But then the human decisions are also providing training data that improve these systems in the future. And again, I think this is bigger than visualization, but I think data analysis systems are a particularly interesting sweet spot as a petri dish for studying this, and that these needs for having an automated guidance alongside human decision making are the hallmark of many aspects of data analysis. And this gives us an opportunity not just to build interesting tools, but actually to better develop some theories. There's one example that I'd love to see us pursue further is this, how do we evaluate trade-offs between agency and automation? For example, under what conditions do people, and it might depend on the task, person, condition, etc., become more complacent consumers of machine recommendations? How do these systems maybe begin to erode at our own agency? And what trade-offs are we willing to accept? Obviously, we want to look at the ways that this obviously benefits us in terms of productivity, creativity, or output. And we might look at new ways to promote critical engagement. So if you're building visual analysis tools, for example, in this area, I encourage you to think about not just what is the specific goal of this tool, but how could usage of this tool be used as an instrument to study some of these interesting issues from more of a behavioral science standpoint. So I think that's critically important going forward if we're going to be creating systems that, again, create a world that we want to live in. So I'm getting near the end of the talk, and as an epilogue, I want to shift gears a bit and talk about accessibility, or as it's sometimes shorthanded, ALI, or A11I, and that's because there are 11 characters between the A and the Y. And this, of course, is study like basically building systems from an inclusive standpoint so that they work for everyone. Or at least that more people have access in new ways and get to exercise their capabilities, even if it's not the most prototypical or dominant forms. And this was sparked in part by this Twitter exchange I had. So John, a great guy, was quoting Ben Schneiderman in an article that was published online where Ben wrote, my strong way of promoting information visualization is to declare that it is such a powerful amplifier of human abilities that it should be illegal, unprofessional, and unethical to do data analysis using only statistical and algorithmic processes. And at first I laughed. I was imagining the FBI kicking down my door if I failed to use Tableau at the right moment in my analysis. But then I thought about it more, and I think, because Ben and I had a heated exchange, all in good fun, and he was like, yeah, we have to say controversial things. So I'm like, okay, well, let me try this on you. And I said, though I appreciate the underlying sentiments, this vision seems to imply blatant violations of the Americans with Disabilities Act. With the exception of color vision deficiency, visualization is overdue and seriously attending to accessibility, and this is certainly in my own work very much included. And it's based on a very simple observation that you've all made, but nevertheless maybe doesn't permeate our work enough, and it's not all of us can see. Right? But more so, there's a huge rich of sensory experience, and I think focusing on visualization makes sense because it's such a powerful channel and is shared by many people. But it shouldn't be the boundary at which we then stop our explorations. Unfortunately, there have been interesting contributions. I will note, for the record, Ben Schneiderman has made wonderful contributions to accessibility in his work as well. So I was just giving him a hard time, but he's also been a leader in many aspects. Some work that exists in the field, and I'm actually very thankful for Eurovis for being supportive of this work, despite sometimes reviewer skepticism, is this visualization or not? Is problems of reverse engineering. Given a chart, what is the inverse problem of getting back to the encodings, the program that constructed that chart, or the underlying data? And there was a nice paper, building on prior results here, at this year's conference. I'm showing an image from that here. But again, we can do better. In this case, we're saying we're helping visually impaired users by giving them a text data table. Which is kind of, to be fair, a little bit backwards in that our whole argument for visualization is tables are not enough, right? And so what are some of the ways we could take this even further forward to build rich perceptual experiences? And of course, I'm far from the first person to call this out. There's some interesting papers. Here's just one. For example, Yvonne Janssen has thought about this a lot, in her PhD work. But I want to think about, interesting opportunities that not only make us more accessible and more inclusive, but also will drive our theory forward. Tactile graphics is one really interesting area because it's actually, in some senses, very close to visualization, but also interestingly different. You can imagine taking an image, doing the right level of binarization, embossing it. If you have good OCR, taking that text, mapping it to Braille, and you can build a tactile graphic. But then what do you do about a colored channel? I have a color encoding, what do I do? And I remember looking at Bertin and thinking oh, texture. Texture is what they did before they had good printers. Right? Before you thought, in this case, no, here's texture as a replacement for color. This is, arguably a categorical encoding that you feel with your finger. And so just from a theoretical, intellectual point, it's just really interesting to think about these different encoding channels that are cross-sensory and maybe might challenge us to think in new and exciting ways. And again, I'm still very early in my journey here, but I think there's a lot of interesting things. It's not just color vision deficiency, though obviously that's important. And I think one area that I would highlight that we are quite aware of issues. And we've done some interesting work, and there's still much to do in computational chart interpretation. But again, I think there's just so much we can do to draw from the accessibility community, but also get back to it using the types of techniques, models, approaches, and mindsets that we've been applying primarily to visualization, but I think could be extended to other modalities or multiple modalities as well. And so, just briefly, some of the research opportunities that I see here include just basic things like for example, D3 is basically open enough that it's really on the designer to do what they want to do. But something like Vega and Vega Lite, we should be generating accessibility tags, by default. There's some people who brought this to our attention or contributing, and things that we could do. You can just take a visualization and think about what happens when this gets published in the world to make it, accessible to the widest range of people. Is I think an ethical obligation that we should do more to meet. But going forward from there, again, I think there's these really interesting intellectual avenues. How do we basically drop the graphical from graphical perception and think more broadly about perceptual effectiveness of non-visual or multimodal displays? How might this challenge or augment our theories, how we do measurement or what concerns we bring? We care a lot about aesthetics and visualization, but that's mostly just left to kind of design intuition and training. We don't have good models for it. However, people in sonification have thought a lot about musical theory and how if something sounds terrible, the sonification is a total failure. So maybe there's something we can learn from that. I know many people in biz have talked about the importance of looking at individual differences. Well, if you start to go in this field, you can see some really extreme individual differences on how much people rely on different sensory channels and that might be an interesting starting point for more of that research. Given my personal interest in like automated design as well as underlying systems, I also think about how can you do redesign. If I have say a Vega light specification that someone put a lot of thought into the design, can I actually learn from that that would guide how to transfer that into, say, a sonification or a tactilization? It's actually really fun to think about, but I think it had very important consequences as well, both for practice and hopefully for theory. So with that, I'll begin to wrap up. Hopefully I've suitably painted a picture of why I think visualization is fantastic and important, and I'm excited about it. But it's still not enough if we want to have an outsized impact as a community. And another way of putting that is I think visualization is arguably necessary, but not sufficient to meet all the challenges as well as the opportunities that lie before us. So, put another way, I think we're capable of more, and that's a good thing. So I encourage us all to have that ambition. Not all of us have to do it, but as a community, if we have a diverse enough output and are accepting of that diversity, I think it will drive us forward in interesting ways. And again, I think we can also do more in terms of connecting to additional communities. And again, I want to acknowledge that many of us do this already, but I think we can do more. So with that, I'll end with a series of quotes. Here's the famous one from Dick Hamming. The purpose of computing is insight, not numbers. And of course, Ben Schneiderman took this and adapted it to visualization. The purpose of visualization is insight, not pictures. And so if I may be permitted to make my own kind of minor increment to this that I think is relevant to today's discussion, it is the ultimate subject of the visualization research community is people, and particularly their interaction and challenges and struggles with data. It is not pictures. And pictures are often a great way to do this, but it's not the only way. And if we fixate on it, I think we are unnecessarily limiting the overall scope of what we might be able to achieve together. So with that, I'd like to thank you very much for your attention. Love to take your questions, and if you disagree with anything I said, I would love to talk about that too. This is just my take on it, and I hope you're all engaged in similar thinking and challenging in your own practice and research as well. So thank you very much.
Jeffrey, thank you very much. This was very insightful and reflective on what we as a community have been doing for some decades already, and where we should be heading. Now it's time for questions from the audience. So before, I don't see any hands up. So let me start. My question, which is in some sense a low-level one, but I kept thinking was, what would be a shared representation between a machine and a human? Why does it need to be completely shared? Why can't we have two equivalent representations?
So I have a longer talk on this. If you're interested, it's a talk you can go to YouTube and Google for predictive interaction, and we'll talk about this a bit more. Also, another one on agency and automation. So in some cases, the specifics of your question is like, what is the nature of the shared representation, and does it have to be fully shared? My answer is that I think, yes, there must be a level that is fully shared, but there is interesting design questions on what the level of abstraction of that shared representation should be. So, for example, in Voyager, the shared representation is Vega-like, but it is represented in a shelf-based UI similar to Tableau within that tool. So that's both in terms of both what is the formalism and then how is that formalism expressed in the UI. And then meanwhile, it's the algorithms that do the recommendation are directly doing basically combinatorial optimization and search over a space of Vega-like specifications. Similarly, in Data Wrangler, it's that the shared representation is the same way a domain-specific language. It is one we call Wrangle, but one that we designed to be a high-level language that is expressive, modular, but also has a small enough surface area that you can meaningfully do more exhaustive enumerations and kind of next steps. One I didn't share today, but which is in contrast to this, is with Spence Green, Chris Manning, and others, we did a series of research projects on basically mixed initiative human language translation. So we've had machine translation engines that then would be used as input into UIs for professional translators. And in that case, I don't show syntax trees, from parsers. I don't show the internal state of the machine learning algorithm. The shared representation very simply is text, in a shared text editor, but with a separation of concerns in terms of what is human-authored text, and so cannot be modified once a person has typed it in, versus what is machine-suggested text, like shown in a different color, that then adapts, that as a person makes changes to whatever an initial translation was from the machine, it then anchors additional new translations on the fly. And that actually ended up being really important because our first version of that was using a traditional beam search algorithm, and then it was later replaced with a more modern neural network system. So in that case, it was actually having the right level of abstraction also allowed us to swap in and out different models underneath. And our decision there was really based on the consideration of the user. So how do they think about the problem? What is the useful asymmetric collaboration model you can imagine with the machine, and then trying to do it from that perspective.
Thank you very much.
So yeah, there's some examples, but the idea is it's an interesting design dimension. There's not one fix.
All right, there are already some questions. People who have mic, please go ahead.
Thank you very much for the wonderful insightful talk, and I can't find anything wrong with anything. I'm just asking a question from operational sort of point of view. If visualization is not enough, how would you call the whole field in the future? So do we call it visual analytics, visual data science, or any good names?
I personally, maybe this is sort of the Engelbart influence, but I like to call it interactive data analysis. It's basically data analysis, but focus on the role of the person, in terms of what their goals are, you understand the procedures and so forth. And to be clear, I think visualization is critical to this, but not always necessary. And for specific projects that are looking at one aspect of this larger picture, may just be, a support technology. And I'd love to see our conferences be accepting of those, understanding the role they play in this larger kind of human-centered data science endeavor. Thank you.
Thank you. I also enjoyed listening to you talk. I was really amazed that you often use the word guidance.
Yeah.
And I would like to know if you think we need more guidance instead of guidelines, if this is a new direction that we can deal with visualization or the other concept.
Guidelines versus guidance. And I guess I'm not sure how you conceptualize it, but the way I take it is guideline is something you write down for someone else to consider and think about doing or not doing, whereas guidance is something where the underlying technical infrastructure is actually in some sense intervening in your process with in the form of a recommendation or an annotation or something else to try and help you. And I think that's really interesting, and I think this would also be very hard to design for in the sense that it's easy to imagine ways that this could go wrong, from just being bad and distracting to perhaps limiting someone's the range of what they consider. At the same time, we know, just from straight up evidence, that people are making flaw after flaw in general analysis procedures, and we might be able to do something to help. And so I don't know exactly what the right answer would be, of course, but I think that's why it makes for interesting research. And more recently, the work that we did with Dominic Moritz and others on Draco, which is basically creating a knowledge base of kind of design knowledge and using that to help drive suggestions of what might be more effective designs. Is one way we've explored this. I think similar strategies, but perhaps with different models and perhaps different inferential procedures, can be applied to other aspects of that data lifecycle.
Thank you.
Okay.
Yeah, hi Jeff, it's Jason Wright, University of London. So you talked about trying to do more behavioural science, which I think is really refreshing using systems to find out about people, but you also talk about a community that expects novel-looking graphics in papers. There seems to be real tension there, and I just wonder if you could reflect on that.
I would concur. It depends. I actually, for the papers that are framed specifically around behavioral science, I find that's less of an issue because people understand that's the framing. I think, and this is, I don't know how other people feel about this, is my personal experience, where I've seen the most friction is where I'm building a system that I think is important for interactive analysis. It may use visualization, but visualization is really just a component. It's not the focus of the work, and then it's deemed sort of out of bounds for our community. And if people want to make that decision, that's fine. It doesn't really hurt us, and then we just turn around and we publish it somewhere else. it doesn't hurt us in the long run. But I do think it's maybe a seeded opportunity, seeded with a C, right? We're just giving up an opportunity for our community to make larger contributions as opposed to just saying, no, that's someone else's business.
Yeah, that's a real challenge for multidisciplinary communities.
Yeah. Helvig?
Jeff, thank you so much. I'm very happy now. I'm very thankful. I think you have been enriching this conference tremendously with your talk. Thank you very much. There's nothing to add. I just wanted to come back to one thing that you said, and I wanted to hear a few more sentences. And it is, in the keynote we saw the easy button, and you have been talking about this potential risk of making very, very powerful tools accessible to a large number of people without a statistics degree. And I think I agree with you, if I understand you correctly, that some things have the right to be challenging, to be difficult, to require competence, and need not to be intuitive at the first glance. We are often met with this requirement. It's kind of an automatic. Very often I see in many reviews I read, but it's not intuitive what you're doing. I think some things may very well not be intuitive. Please say a few more words about it. This is very interesting. And do we have a chance? What should we do? Are we accelerating against the wall, making everything easier and more accessible and one click and...
Yeah, I think at least from the perspective of automation, it really depends. I'm not saying don't get a car with anti-lock brakes. I trust that. Like I say, I declaratively communicate to my car that I want it to stop, and particularly I want it to stop incredibly quick, and then it makes decisions on how to pump the brakes and everything else. That's an example where you have an engineering process in place that understands the context and everything else well enough that the easy button is a safe, reasonable, and basically in most cases provably better option. But there's many cases where the notion of the easy button terrifies me, because I expect people will push it, they'll trust the system, they'll take what comes back, and not maybe realize whatever types of flaws or mistakes that might be then induced as a result. And so you can't divorce it from thinking about it, not as here's a solution and it's done, but really thinking about what is the engineering process or design process that we need to do to make those decisions, in an informed way. So, yeah. Hopefully that speaks to your question.
Thank you.
Hello. Very formal.
Oh, hello.
Thanks. I want to follow up on this question specifically. Fortunately enough, Elvig took a lot of things away that he formulated much better than me, but I was thinking the other way around. Do you think that our field is something for an unexperienced user, and especially with the advent of so much information being available and being misused, to educate people, to make more informed decisions and understand better basically what's going on in the data, and if it might be misused to mislead me in taking a wrong decision or leading me to some wrong conclusions?
Yeah, it's hard to answer that. It obviously depends on numerous factors. I think, even what you mean by a novice user, are they novice in terms of how they reason about the domain in which they're trying to work? Are they novice in terms of the tools, or in terms of just the mechanics of it, or novice in terms of underlying methodology? So all those things will come into a role. One thing that we've thought about, it's reflected in a lot of our systems, is thinking about, well, how do we take what people are trying to do and then allow them to specify their intent at a higher level of abstraction? So obviously, declarative languages is one strategy from which one can try to do this. But for example, if people are less, knowledgeable about the specifics, just look at, for example, writing code in R. You're going to do your data prep with one tool, you're going to use LM or GLM or Elmer or something else, and you have to know what a random effect is, and so it's very much at this low level of abstraction where if I can state in still some formal but meaningful high level, this is the question I'm trying to answer, you could imagine they not only trying to automate some of the decision making around that, but not just automate, run, and be done, but maybe automate and even have ways in which you then ask back. Does this reflect what you want to do? What are the ways that we visualize or otherwise present, either both inferred model structures or inferred results, right? These are types of forms of guidance we might consider. And so I think the most concise answer to your question would be, this is exactly the kinds of research questions that I'm excited for us to address, and not purely within a framework of like, this has to be visual. I think something with like some automated decision making with a reasonable comparison of alternatives and some description might be better than like 16 visualizations that all have interacting views that are hard to understand. Like, that's more complicated in some cases than like even a simple equation in text, right? And so visualization is very powerful, but you still have to, it doesn't mean it's always intuitive, for example.
Great, thanks. Thanks very much, Jeffrey Anderson and Sheffield University. I really agree with the need for our community to reach out to the other disciplines that are neighboring in visualization in the context of that. And I think we're doing great. I think our community is thriving, as you point out. However, I also see that in graphics and in certain parts of this, many of our researchers are going in the direction towards the machine learning venues instead. So there's a bit of a brain drain in that direction. And your nice diagram, we need to, in some way, inverse that flow and get people coming back to us again. So I was just wondering, what kind of mechanisms would you like to see to make that happen on a very practical level?
Yeah, that's a great question. So if you hear the question is, how do we basically better catalyze this exchange between communities that's mutually beneficial? I would again point to the same example I had earlier in terms of I think what's happening between subsets of the Viz community and the database community. I think it's because I've been the most involved in that. I found to be really enriching. And part of that is like you have these events that occur at the respective subdisciplines conferences, but are actually richly connected. It's like the same set of people who are talking and helping organize, like the data systems for interactive analysis at Viz versus the human-in-the-loop data analysis workshop at Sigma. You're seeing the same groups of people starting to publish in each other's conferences. And so I don't think there's like a shortcut to building community other than building community.
Hi, Jeffrey Heer from the University of Maryland. I was thinking about interactive data analysis and trying to think through. It's really appealing, and thinking about how I explain what I do to other people. If I say information visualization or things with visualization, they think of bar charts maybe, or maybe they think of Tufty. But then I have to explain that there's an interactive part. That's where it gets important. It's interaction, but then it's also as cool and diverse and pretty as Tufty. But you can move stuff around. And so interactive data analysis maybe doesn't capture that, but it does capture the thing that is missing that I keep having to explain to people. And also, Viz is a really nice one-syllable name. So what would it
Yeah, well, first of all, anyone has better names, fantastic, let me know. And I'm not advocating for changing the name of the conferences or anything like that, just to be clear. I think it's more about what we be accepting of that. I think we need to be forming and there are like visualization for data science, which is a symposium at Viz, pushes in this direction and tries to capture both of those aspects, right? But I think having these events that connect different communities together, and also just being accepting of work that's a little bit broader, even if Viz is still going to be this like the central point, that'll be like sort of the medioid of our work. I think that's fine. I think that trying to be too broad or too vague is also a pitfall that one can fall into. But I do think that we have to have that right level of flexibility to allow us to grow and go in new directions. I think this also, we'll see how the restructuring of IEEE Viz plays out, with the idea that new symposium and conferences are supposed to be able to come up and, basically and then, flourish and, graduate, and maybe in the future some conferences might actually demote to a symposium or disappear entirely. We don't know, but we're trying to build a governance structure for that. And so you can imagine some of these things being reflected in some of these new sub-organizations that might be produced. And so this might actually be a great trial balloon for some of these aspirations that our community leaders have had.
Thanks very much for the talk. It was really insightful. I really enjoyed it. I was wanting to get your thoughts a little bit more on the interdisciplinary aspects of what we're talking about. So we all know, from working with domain scientists and when we're building applications, the problems we have in communicating with them. They have different languages, they have different models or conceptualizations of the problem and the solution that they have. I guess exactly the same thing happens with the different domains. So when you've got a group of people sitting around chatting, you've got people from the database world, you've got people from the AI world, they all think of the problem in the way they've learned to conceptualize the problems, and that leads to lots of communication issues and potential problems in the resulting solutions that you come up with because you think you're talking the same language and it takes ages till we realise actually you're talking something different. So I just wanted to hear your thoughts a little bit more on how we improve on that so that we minimise any potential issues or communication problems or errors that might arise from that when we work together in that area.
Yeah, it's about fostering those interdisciplinary connections and communication and understanding between groups. One, I think personally, I think almost everyone, not everyone, but the majority should have some kind of design training or background, because part of what design is about is learning to communicate among different stakeholders and then use that to generate potential new forms or new solutions, etc. That's oftentimes what they're really good at. I think the other thing is a bit of a selection bias. The reason I love working in this field is because I love diving into another field and understanding it. I find it both personally as well as professionally rewarding. And so that's why I think we're uniquely suited to that, because we do these kind of things. Like, yes, there's challenges along the way, but I think many people in this room do this to some degree regularly. And that's why I think we're maybe better positioned than some other fields to contribute to some of these questions that were raised. The other thing that's funny, I remember Stu Card saying to me once many years ago, like, yeah, on paper we say that we're all about forming new interdisciplinary teams, but that's just a ruse. It's really just a step along the way to creating truly interdisciplinary people. And so I was affected by Stu's charming deviousness, and so I would apply that to this situation too.
Jeffrey Heer from University of Wisdom. Thank you for this exciting talk, Jeff. I measure the value of these talks to me as the number of thoughts I get afterwards and challenges. And I particularly subscribe to your conviction that the human should be in the loop. And so the question is, we've discussed, so one of the tenets of HCI is that users should be in control, person should be in control. And we are apparently relinquishing that control because that gets more papers published at AI conferences for some reason. So my question is there a design discipline behind this whole idea that humans and algorithms should cooperate to produce normal things? And let me try to be a little provocative here. Is there a middle way between the easy button and the bench dialer button? The one that says to the user, hey, you're falling asleep at the wheel.
See, so in terms of design disciplines, I think there's a lot of interest in this in our community, in the HCI or CHI community. There's also a conference on intelligent user interfaces. So certainly people spread around. If anyone's interested in this, to me, the starting point is always Eric Horvitz' 1999 paper, Principles for Mixed Initiative Interfaces. Like, that's just start there and read. I think that's come downstream of that. And I think what's interesting is I think we need more studies that are really just focused on here are some different design aspects. What are meaningful, either experimental or deployment conditions in which we can actually see how then this plays out. And there are things, for example, where you can show very clearly that people are bad at something and you want, I don't know if you call it the easy button, but you'd actually prefer automation. Like, we have a paper in submission to Tokai, which was like, here's a bunch of things in interactive feature selection and why you should kick people out of that loop. They either make the model worse or they waste hours of time. It's only under the certain like modeling conditions we tested, but I think that's part of this thing. Like that might not be about visualization, but those results are very, very relevant to the design of visual analysis systems, right? And so I think just in pointing to some of the type of work that we might want to do there. So if you want to know whether or not the car should wake you up, right? Like, well, what is a meaningful set of design alternatives and how would you think about evaluating them? It's probably, you know, even if you were just doing it as a thought exercise, let alone an actual research project, it's probably the place I would start. Yeah, thank you very much.
There are two last questions.
Okay, yeah, we go over a little bit over.
Okay, so Professor Thomas, you earlier on you covered a ton of different things that involve you think back some of the earlier stuff, and you mentioned the multiverse analysis and then how it indicates paper and how you can p-hack your way into all kinds of interesting results. And of course, there's been a lot of criticism, I think, especially for the Eurovis systems that we build, is that, including certainly Tableau, that there isn't a p-hacking system, right? You can always p-hack or sort of you can find the things you want. If you do analysis and tweaking. But I wonder if we sometimes use the wrong metaphors, or the wrong science here, because we like to think about statistics, and statistics thinks in terms of sort of running experiments and having a universally sample problem. But when you talk about business data, that's not the same thing. Because if I look at my sales data, that's not a sampling from a large universe. That is the data. That is all there is. And so I wonder if the methods that are underlying and some of the thinking that are underlying some of the systems actually need to change as well.
Yes.
When we're moving away from actually supporting scientists to other kinds of using of data.
Yeah, I think it's an excellent point. I mean, for the short version, and you might remember there was the Kai paper by Scraggin et al. That looked at the multiple comparisons problem in viz, which took a very much a frequentist statistics perspective, let alone tested it all on open-ended tasks with no goals on undergraduates. So there's probably, you know, some limits to how you would generalize from that work, though I by and large love that paper. But Jessica Holman and I wrote a response to that where we talk a lot about these issues. What are you doing when the data is not a sample? It is the population. What is it when you can't just formulate a hypothesis and go collect more data? This is the only data you're going to collect. And what are different ways of thinking about what people's goals are and what their processes are? And one was just even taking a more sort of Bayesian perspective. It's like, well, how do we account for what the person's expectations and beliefs already are, and then view the data through that lens? And that gets into the whole line of elicitation work that I think Jessica is really thinking in an innovative way about. That might be a better fit than sort of the classic, you know, frequentist perspective to some of these issues. So I don't know, yet what the best answers will turn out to be, but I would just completely agree with your question and also note to some of these ways that some people in the field are already beginning to think about these issues. Yeah, thank you.
Thank you very much. Your talk is great, and I agree to everything that you said. But I cannot help thinking that almost everything you said is the content of visual analytics research. So visual analytics understands that visualization is not enough. Visual analytics divides the layback between computers and humans. And actually, this is the science of analytical reasoning facilitated by interactive visual interface. Maybe besides, with the exception of sonification and tactile interfaces, everything that you said is actually the topic of research of visual analytics. Do you think visual analytics is not enough, or it is not fulfilling its tasks, or what is good with visual analytics?
Yeah. So I think I understand your point. I would respond in two ways. I would be perfectly happy with everything you said if you just dropped the word visual. Doesn't have to, I think that's a primary modality that we'll typically want to use, but just assuming that from the beginning and sticking it in the definition seems to presume a solution before fully understanding the natures of the different problems. And then the other was, even if I, you just completely accepted the visual word in there, I still like to think, and then say, oh yes, but we know that it's not enough, and these other things. I'm like, well, I think that's not clear in my experiences in terms of both reviewers and paper chairs of these areas. And so if we put you in charge, fantastic. Right? But otherwise, so I do see that actually playing a role in terms of how people do boundary policing of what is and isn't acceptable work in the field, even if that is not aligned with the fundamental definitions. So again, that's just my experience.
last 15 seconds.
15 seconds. Comment. I think for your suggestion of IDA, I just wonder why not drop the words D since you've been talking about model visualization as well. So IA, which is wonderful, is the reverse of AI.
This is already very prominent in the contemporary debate. IA is typically interpreted as intelligence augmentation. I think the only issue here is that we have a slightly more specific focus, and that we're really kind of oriented on data-driven decision making. So if you're going to go ahead and use IA, great, but then realize that you just hit a namespace collision with a much larger. Yeah, thank you all very much.
Thank you very much for this very lively talk, very inspiring, and very lively discussion from the community. This was lovely and for the summit of this Eurovis 2019. Thank you. Thank you.